Hey everybody, Lars here. Back for the second review video for Unit 5. Like I told you, I want to spend a lot of time this weekend getting you all of the resources you need for this unit so you can have them. And you can start watching videos and reading all your stuff and, getting things done for this unit. Because it's long and it's different. So I want to make sure you have everything as soon as possible, all right? All right, without further ado, because I just bought my copy of Star Wars The Force Awakens on Amazon Prime. And I'm halfway through it. But then I realized, oh no, you know what? I have to stop and I have to do this video for them. Here's Spider. Spider is the IDE that comes along with Anaconda. I've been playing with Anaconda. I'm going to show you some stuff with that soon. All right, but enough of that. I made some code for us to look at. So, just as a quick review of classes, I have a class here called Animal. And animal basically just takes two variables, the name of the animal and the weight of the animal, and has one little method here called speak. So if I run speak, it prints sound. Because it's a generic animal, we don't know what kind of sound it makes. But we're going to deal with that in a second, because this video deals with two concepts that come along when we deal with object-oriented programming. They're called inheritance and polymorphism. And real quick, I'm going to review this class with you, and after that, we're going to look at both of them with this same set of code. So the first thing I'm going to do is I'm going to get a variable called the animal, and I want that variable to hold an object of class animal. So let's call class animal, and let's give this animal a name. We'll call it not Frad, a mix of Fred and Brad. Frad. That's kind of funny. Let's go with it. Frad. All right, Fred is a yuppie dog, and Fred is let's make Fred chubby. Let's say he's 75 pounds. That's pretty big for a dog. Okay? And we are going to print the animal dot, and let's just print his name. Get name. Boom. So now if we run this code, we're going to get something? Yes, we're going to get Fred. All right, let's get this centered so we can do it. All right, I love it. All right, let's trace through this code really quick so that we know what we're doing here. Like a function, when you declare this class, it just gets read into memory, and nothing really gets done with it. Okay? We can show you that by commenting everything out, and you can see when it runs and everything is fine, but nothing really happens because we don't do anything. All we're doing there is declaring the class. The first thing we do that actually does something is here where we declare our variable, the animal, and make it equal to class animal. So we're getting an object of type animal with these parameters. And what happens is when we say we want to instantiate the object, the constructor gets run right here. The dunder and init dunder is the constructor. Self is the name of the thing itself, the animal. That's going to come into play later tonight. And Fred, the name, gets put into the variable name, and the weight, 75, gets put into weight. So what do we do in this particular constructor? We just set our instance variables. Self.name equals to name, Fred, and self.weight equals the weight, in this case 75. Okay, so now the animal is a variable that points to an object that was created with class animal that holds two instance variables, the name, which is Fred, and the weight, which is 75. So on the second line here, we use print statement, and inside it, we have the animal.getName. So we're going to run a method on this object. The animal is what? It's an animal type. So we go up to the animal class. Is there a method called getName? Boom, boom. Yes, there is. What does getName do? It doesn't take any parameters we can see. All it does is it returns the instance variable self.name. So in the case of this particular object, that name is Fred. So this method returns Fred, and the print statement prints it, and we see it right there. Okay? So that's the basics. We created an object with our class, and now we can use it to do the different things we have to do to solve our problems when we write a program. You can see up here I have a constructor and these two variables. These variables have both getters and setters. A getter to return that variable, a setter to change it if we need to change it from outside. We have the same thing with weight. And then, as I said before, we have this little speak method. If we wanted to run it, we could run it. As a matter of fact, just to see it, I will do that. I do not have to use print because, as we can see, we print right there. So we should be good if we just run the bad boy. And we are. Okay? All right. Now we've reviewed classes and we're up to speed on that. Now we need to think about what I wanted to do if I want to get more specific. Let's say I wanted a class for a cat, okay? And when I create my cat class, I don't want to retype all of the things I've already done for animal. I mean, my cat's going to have a name. Well, I have code for that already. My cat's going to have a weight. I have code for that too. Is this a case where I'm going to have to, retype that code all over again and do something completely different? The answer is no. And I'm going to show you what we do. Let's say I wanted to, hey, how about giving me some space down here? Let's say I wanted a class cat. And I don't want to retype all of that other stuff. I want to actually use what's up there in animal. Well, I can do that if in my parentheses I say animal. Okay, you see there's no parentheses up here because that's what's called a base class. But here I inherit, and that's where the word comes from. I'm inheriting from the animal class. It's like I want to use that as a base and then build on top of it, okay? So everything in here I'm going to be able to use when I create my cat objects. But there's one little rub here. What's the first thing you do when you create a class? You create your constructor. So you do self, then I'm going to do the same thing that I did for animal, and then my cat's going to have one extra thing. We're going to give it a color. Okay. Now, tricky is strong. This isn't the tricky part, but what we have to realize is when we're creating an object and we inherit from another class, basically what we're doing is we're creating that base object first. And then we're putting the stuff on top of it when we come out to our regular class that we're creating right now. So what I want to do when I create my cat object, I'm going to be passing in name, weight, and color. Well, the first thing I want to do is go get an animal object with name and weight, like I was using animal in a normal way. And then in this right here in this same constructor, we're going to add color. And the way we do it is this. I'm going to create an animal object right now, but I'm going to do it from the cat class. And the way I'm going to do it, and it's actually pretty cool, is I'm going to call the constructor of animal. And I could do that by saying animal and then dot dunder init dunder. And I'm going to call it now. And this is the only time you're going to have to break this rule. When you call a constructor of what's called a superclass, you do want to put self in the call. Okay? Usually self is implicit. You're calling it from outside the object. Python knows that whatever that object variable name is that object and it passes it up. But in this case, we want to tell class animal, hey, I'm the object that's being created for the cat, but I'm coming to create an animal object first, and then I'm going to come out and cat myself. So in this instance, we do want to add self. You don't have to think about it that hard. Just remember when you call this the constructor of a superclass, you want to use self. Okay? And then what am I going to pass it? Well, I'm going to pass it name. I'm going to pass it weight. And I'm done. Okay? So now I've called the constructor of the animal class, and I have it set up just the way it wanted to be set up. So I'm in good shape. So now what's left? Well, I do have that color variable. I treat that just like any other instance variable. I say self.color equals color. And it's only accessible when I do cat. Now, because I have a new variable, I want to do my getters and setters. So I'll do that. How about I do the syntax properly? Return self.color. Nice. Def set color self. Here I want to take color. And then I'm going to say self.color equals color. Good. Getter and setter right off the bat. Now, there's one more thing I'm going to do here. Remember in the animal class you had a method called speak, and it just printed sound. Well, I'm not a generic animal anymore. I am a cat, and I know what cats sound like. So I am going to write over this. And it's funny I say over. Print meow! Exclamation point. Because what I've just done technically is called overriding. I have overridden the animal method, and I've written my very own speak method for the cat class to make my cats say meow. That will be understood more in a second, because I'm going to now use it. And I always say this, but this is the first time in the course, really, where we've gotten to the point where I can't keep all the code on the screen because we're getting complicated. You guys have done a lot in the last 6-7 weeks, if you think about it. So now I can't keep all the code on the screen. I'm going to be going back and forth, back and forth. All right. I now have a cat class. It inherits from animal. So let's use this cat class and trace through some of the code to figure out what's going on. I'm going to call my cat Felix. Felix is going to weigh 15 pounds, chunky cat. And Felix is going to be orange. So I'm going to call Felix, let's say, I should say the cat equals cat. And do that. And then I'm going to print the cat dot get weight. So I can explain that. And then we'll do the little speak thing after. All right. So first of all, let's Zots this code out so we can just keep it with the cat. Now, boom, 15. Excellent. So, what's happened here? Forget this code up here. We're just going to deal with the cat right now. We have the cat, a variable, equal to cat, and then we give it Felix, 15, and orange. So, the variable, the cat, in that variable, we want it to point to an object created with the cat class. So we come up to the cat class, and we run the constructor. Def init self, which in this case is the cat, name, Felix, weight, 15, color, orange. Okay, we're good. Drop down a line. We call the constructor of the superclass, or the class we inherited from. So animal.init with self, name, and weight. So we come up here. Self is the cat. Name is Felix. Weight is 15. So we set self.name equal to Felix and self.weight equal to 15. Okay? And then we go back to where we left control. Now we have self.color equal to color, which is orange. The constructor is done. We return control back here. So we now have an object, a cat object, pointed to by the variable the cat. Okay? That holds 3 instance variables: the name, the weight, and the color. So, second line, and this is where it gets interesting. Print the cat dot get weight. Okay, the cat is what? It is a variable that points to an object created with the cat class. So let's go to the cat class. I am calling a method called get weight. So let's go look. Under init, no. Get color, no. Set color, no. Speak. Uh-oh. When I go to the cat class, I do not find a method called get weight. So what does Python do? Python says, did I inherit from anything? And we look in here and we go, aha, we did. We inherited from the animal class. So Python will go up to the top of animal and say, all right, let's look again. Do I have a method here called get weight? Init, get name, set name, get weight. Here we go. So now I finally find it. Get weight self returns self.weight. This particular object does have a weight variable, and it's equal to 15. So it's going to return 15 in here, and that's what gets printed. And that's what we see over here. Okay? Now, one other thing I'm going to do here is give you an example. If I were to just print the cat get color, All right, I got my other things back now. I got my animal things back there, but let's skip down to the end. If I print the cat.color, what happens? The cat is what? It's a variable that points to an object that was created with cat. So I go to cat. Is there a method called getColor? There is. So that behavior was defined here in cat. So then I just return self.color. In this case, it's orange. So boom, I get orange. Okay? Now, there's one last thing that we're going to do, and it speaks to the second thing we wanted to talk about tonight. Let's say I have my animal. So I have the animal dot. Can't type tonight. Speak. And I have the cat speak. Okay? Two objects. I'm running what is seemingly the same method on both objects. And I am now, I'll leave it, whatever. You can see it. You won't get that confused. And look at that. The animal speak says sound. The cat speak says meow. Because the animal speak was created with the animal object. So when I look to that object and I come down and see speak, it prints sound. But the cat was created with the cat class. So the first place I look for methods is the cat class. And if I find it, I run it, and I get out of Dodge. So I never get to this point. I have overridden this method, and now print meow. And this is an instance of what's called polymorphism, which is a really complicated name for something that just means many, poly, and the morphism means change or form, and in this case it's forms we want to think of. Polymorphism basically means many forms. You can have the same name for methods, and depending on the context you use it in, it has different behaviors. Because when you have different animals, you may have a speak method for all of them, but the cow says moo, the dog says woof, the cat says meow, blah, blah, blah. It's a trivial little kid example, but that's basically the gist of it. You want to create a scenario where things that may be named the same or may have, similar behaviors are different depending on the object that you're calling it on. A lot of other languages, Java, C++, also incorporate something called function overloading when they deal with polymorphism, so that you have the same name inside a class defined a bunch of different ways because they're called with different variables. Python doesn't really support that, so we don't go into it too much. I'll explain a little more about what that's about the next time we make a video. I'll probably do one Sunday morning. And we'll talk about how Python really doesn't support overloading, but it's okay because there's a way to do it. We're more talking about overriding the methods that are in parent or super classes when we inherit. But for polymorphism, like I say in the slides and like you can see here, we're really just talking about classes like animal, dog, cat, cow. They would all have a speak method that would utter whatever they say when they speak, and they would all be different. So that's basically the gist of polymorphism. And it turns out when you simulate systems, it's actually very realistic and very handy, because while on the higher level, sometimes we have a lot of similar behaviors, when you dig down deeper and you get to different individuals, those things are slightly changed or nuanced. And as far as programming is concerned, this is a good way to represent that. And as you get going and you get more complex with your code and you start using Python to do things, you're going to see how that works, and you're going to see how it really comes in handy. Basically, you can get libraries and libraries of generic classes that do very generic things, and then you're going to say, oh yeah, but my thing is a little bit different and needs a little bit of a change, and that's great. You take the base class, you inherit it, and you just make your little change. And then all of a sudden now you've got something that's pretty close to what you want to represent in the real world. So I'm going to take this code like I always do, and I'm going to put it up on Sakai for you. And that way you could play around with it, use it. You could use all the different methods, play around with all the different things, and you can see how these things work. So that's basically it. I know it's a simple overview and it's fairly quickly, but I want you to be exposed to all of these things and see how they work. So I the dice example now. You have the student example. You have the bank account example that I did in the first video. Now you're going to have the animal and the cat, and there's going to be even more in a couple of days. We're going to add a dog class to this, and we're going to do some other things when we talk about what's coming up in a couple of days. And if you've read the slides already, you know it's basically class variables. We're going to look at deconstructors, and we're going to look at overriding some other methods in superclasses that are useful for us to know about. All right? All right, good. Announcements. Let's see. Graded all the quizzes. Everybody seems to be in okay shape. The boys, if they haven't done it already, tomorrow we'll do all assignments. So I hope that by the end of the weekend I will have sent out emails with all of your Unit 4 grades so you know where you stand and whether you need to do the extra credits that have been given out this week. Second thing I'm going to announce is you got your assignments. The first two are the ones that I expect you to do for regular credit. The first one, to create the class that represents a deck of cards, is 8 points, and then using it in a game is the 4-pointer. The next two are extra credit. So if you forgot a forum post once, or you've done crummy on a couple quizzes, or you're lacking points, now's your chance to show me you're working hard and do those extra credits. The first one is just, the second assignment is to use your deck of cards in a game of Acey-Deucey. And if you don't know how to play it, just look it up in Wikipedia. And the third one, the first extra credit, is to just use that deck of cards and play blackjack. So it's implementing another kind of game with your deck of card class. The fourth one is actually a pretty neat little program that Eric came up with in the fall. It's pretty data sciencey. It has to do with Zipf's law. And give it a read and give it a once-over, and it's very interesting. You do need to have Matplotlib running in order to do it. But go check out that assignment. I think that's pretty neat. If you do that one, that's 5 points, okay? And those are points over and above the points that I average in. So if your normal unit has 24 points and you do all of the extra credit, you could get like 30-something, divided by 24 this unit. You can get a lot of extra stuff done. So if you're a little bit behind, you want to, show that you're working hard and show that you're dedicated, doing those extra credits is a great way to get that done, and it's a great way to get extra points, all right? So, pretty good shape, getting you the materials as best I can. Let's see, you have the assignments, you have all your readings. This will be the second of the 3 videos, so once I get you that third video, I think you're going to be good. Then I may, with the intervening week, do a small little video on Anaconda, because it's kind of neat, and I want to show you some stuff in there. It might make your lives easier down the road. Very, very data sciencey, which is why I like it. I like it a lot. All right? All right, I got to go. Star Wars doesn't watch itself, but it's already 2 o'clock. I guess I could stay I guess I could stay up until 3 and watch it. All right, like I said, I'm going to put this code on the web. You're going to be good. Everything's going to be great. Life is good. All right, I'm getting out of here. So you have a good night, and I will talk to you in a couple of days. Be good. Bye.